This is section 3.04 from Unit 3 Notes, Linear Regression. Today I am, as in you are the student, learning different values associated with linear regression equations so that I can write, interpret, and use the linear regression equation and find the percent of the variation. I will know I have it when I can use technology to find and interpret the equation of a linear model. The specific TEKS we're looking at for today's lesson is 9F. Okay? Linear regression equation. If you watch the videos or if you've done the lessons for 3.03, a lot of what we're fixing to learn, we've already learned how to do it, but now we're going to interpret what we found and inform it into a linear regression equation. So, linear regression equation, aka finding the line of best fit. We're going to use other values from our calculator to write the equation of the line that passes through most of the points on the scatter plot. So if you've already learned how to use Desmos or how to use the TI-84 to find the correlation coefficient, VR, like we did in the previous 3.03 video, then you will know how to do what we're fixing to do in a few moments. But if you still like a refresher on what to do, just continue watching. Otherwise, you can go ahead and skip to where we start doing some examples or the U-tries. So, linear regression equation, just remember that when we find the equation, we need two different values. We need the slope and the y-intercept. The slope is the m value of whatever it is we're fixing to find, which will be different depending on the calculator that you use. Desmos, it'll just straight up show you what m is. TI-84 interprets it as a. A is the exact same thing as the slope. And then the b value for both is the y-intercept. Excuse me. So those numbers that we find in our calculator will be then used in the equation, replacing the m and the b, or the a and the b, whatever it is you're using, and that will be it. That will be our linear regression equation that we will then use on word problems or whatever problems to answer questions, predict values, etc. Okay? So let's start with Desmos. So if you have not used Desmos before, just if you have the Class Kick notes open, I do have the link right there and a video of me going over how to use the Desmos calculator to create the line of best fit. We're also going to be doing it in this video too, but just so you know, for future reference, the videos are linked in the notes themselves on how to do these. Okay, but anyways, go to desmos.com. I have the link highlighted right there. desmos.com/testing/texas/graphing. So we are going to enter some values on a table. So from this side right here, we're going to enter it into a new table in the first line of the Desmos calculator. First thing you need to do to get this table is click the plus button and then select table. And then from there, enter your values. X's will be under the X1. Y values will be under the Y1s. So we have 1, 2, 3, 4, 5, 6, 7, 8. And if your X's have a particular predictable pattern, you can just hit enter and it'll autofill it for you. The Y1s don't have that, so we got to enter all of these manually. So 25, 31, 34, 36, 40, 41, 47, and 55. If you want to see what they look like on your graph, you can zoom out and you'll see those dots right there. We're going to create a line of best fit that passes through all of those points as best as possible. Okay? So to do that, we're going to enter this equation into the second line. Now, if you don't know where this squiggly is in the expression, simply hold shift and then press the key that's right next to the 1 right there. And then you will get it. Alright, so continuing on line 2, we're going to type the following. Y1 squiggly x1 plus b. And then you'll see the line of best fit. It's pulling all the data from right here. It's using its own calculations to then create the equation and then give you the values that it used to create that equation. So as you can see, we got the r squared, which we're going to learn in this lesson a little bit later. We got the r, which we learned in the previous lesson about correlation coefficients. And then you have the m and the b value. These two values are what we're going to replace into this equation to get the line of best fit. Okay, so let's go back to class kick. And again, this is just me showing y'all those things that we found. I thought I had a thing for the equation, but I guess I'm going to write it right here. So our linear regression equation is based off of y equals mx plus b. We're going to take m and b and replace them with the values that we found using the Desmos calculator. So this will turn into y equals 3.75 x plus 21.75. Okay, right there. And then this is our linear regression equation. Okay, and just to show you what I mean, I'm going to type it right here. Y equals 3.75x plus 21.75. And then you can see this line is red. It's the exact line that we have right there on line on 2. Okay, it's the exact same thing, but this is the actual equation that we use for solving problems. Okay, that's it for Desmos. Now, if you have a TI-84 and you just prefer the TI-84, I'll show y'all that now. But again, if you just for whatever reason forget, you can just watch this video, or there's also located in your notes for 3.04, linked right there. So let's pull out the calculator. First thing we're going to do is turn on diagnostics. So that's what these steps are saying. So we're going to, if you already did this, then you don't have to do it. But if this is your first time turning on the diagnostics, this is very important. You need to do this. Otherwise, you won't have something showing up for certain problems that we're going to do. So to turn on diagnostics, you're going to press second 0, and we're pulling the catalog by doing that, by pressing second 0. And then from the catalog, either you scroll all the way down until you see diagnostic on, or you can look for the green letters right above some of these buttons and look for the letter D. If you hit it, it'll take you to the section that we need under D, and then you can arrow from there until you find diagnostic on. Just a quicker way to navigate through the menu there. So diagnostic on, hit enter, and then enter again. Done. You don't have to do this any further. Unless you reset your calculator, then you got to do this again. Otherwise, it's on permanently. So now that we have it turned on, we're going to enter the data set into our calculator by doing the following. We're going to press stat, go to the right to, hit stat, and then hit enter for edit. And then we'll be given our list of numbers right there. Okay. Now, if you have a list of numbers from a previous problem that you did, hit clear, highlight L1 or L2, wherever the list is. Do not hit delete. Hit clear, and then enter. And then it'll erase all the numbers that you enter right there. If you hit delete, it'll delete the entire column, including L2. And there's a few ways that you could bring that back up. So either you highlight it and then you enter your list by pressing second stat to enter the L2 list there. If that doesn't work, then you have to second plus 712 to reset your calculator, and then it'll pop back up right there. Okay, so anyways, now we're going to enter these values into the calculator. L1s are usually your X's, so age, in this case, usually the left side of the table, or the top side of the table, depending on the orientation. Age is our X values for L1. So we're going to type 1, enter, 2, enter, 3, all the way up to 8. Okay, and then we're going to go to the right for L2, all the Y values, or all the values on the right side of the table, or bottom, depending on the orientation. These will be our L2 values. So 25, enter, 31, enter, and so on and so forth. There we go. Make sure every one of these numbers has a pair and they're not blank, because otherwise when you calculate this, you'll have an error. It's fine if the bottom row is blank, but if any of these are blank, then there will be an error. Okay. So now to calculate the line of best fit, we're going to do the following. We're going to press Stat. We're going to arrow to the right to Calc for calculations. And then we're going to press the number 4 for linear regression line, or just hit the number 4. Make sure L1 and L2 is there for the X list and Y list. If not, you can press second Stat to get the list. And then whichever one you're needing, you could just hit enter for that one. You'll highlight it and then enter. Then go down to calculate, hit enter, and it'll show you what it is, whatever you calculated from that table. But again, you need to turn diagnostics on to show the rest. So in my example, I completely forgot. I reset the calculator. So I need to simply go to diagnostic on, turn that on, and then do everything, do everything again. And then there it is. Okay, so now in this case, A is our slope, which is 3.75. B is our y-intercept, which is 21.75. So to write that equation, I'll write it right here. So the linear regression equation is y equals ax plus b for the TI-84. And we are going to replace the A and B with 3.75 and 21.75. So we get the following equation. Y equals 3.75x plus 21.75. Now, if you ever want to look at the graph on the TI-84, you can hit... well, first, let's go to y equals. We want to do plot 1 and plot 2. So we're going to highlight. So y equals is at the top left. Once we get to this screen, we arrow to the up where it says plot 1 and plot 2. This is going to plot the dots on the table that we just used from right here, from stat. So plot 1, plot 2 will then put the dots on the graph. When you hit graph, though, you won't be able to see it, but you can zoom into it by pressing zoom and then going down to option 9, zoom stat, and then it'll zoom your window to those particular dots. Now, if you want to know if the line of best fit is going through your dots, you can go back to y equals and then enter the equation right there. 3.75x, whoops, that's not x, which we can press this button right here next to the alpha. It'll put the x right there, and then plus 21.75. And then if we hit graph again, it'll go, make that line go through those dots. And there we go. If you ever want to get it back to normal, I think you just press zoom standard, zoom 6, and then it'll turn it back to normal. Then you can see the line kind of off the graph a little bit there, but this zooms it back to its standard mode. And you can toy around with that all you want. You can probably look up videos to better understand how to work the TI-84. But also, if you want more help with that, let me know. But that's basically all we need for this. That's it for TI-84. Okay, so here's the example of the linear regression line, just to show y'all what we just talked about. Again, this is TI-84. This is Desmos. Both will create you that exact same equation. So just matter of preference. Whichever one you want to use, whichever one you just have an inkling for or a liking to, use that. You're still going to get the same answers. All right, so you try number 1. Write the equation for the line of best fit. Round to the nearest hundredth. You have a table here. Choose one of the ways you want to do this, either through the TI-84 or Desmos calculator. I have the steps right there for y'all to read through and try this on your own. Okay, and then underneath, if you want to check to see if you got the right values, just move those boxes and you'll see it. So at this moment, go ahead and pause the video. Try this on your own. Otherwise, I'm just going to go through and show y'all how to do this. Excuse me. I'm going to rush through the explanations. I'm not going to go into detail about too much because I'm assuming you've watched how to enter this on the previous part of the video. So I'm just going to go through very quickly how to do this. We want to write an equation. So in order to write an equation for the data on the table, we need to create a table using Desmos, if you decide to use Desmos. I'll show y'all how to use TI-84 in a little bit. So first, we're going to type in the x's, 14, 16, 18, 20, and then we have another 20, 25, and 26. Okay, with the 14, it has a 45, then 45, 33, 26, 16, 14, and 9. And again, it's not required, but you can see from the graph, you can zoom out, zoom in. We got a negative correlation going on. So whatever our equation is, you should expect it to pop up as such. Now on line 2, to create the equation, we're going to type the following: y1 squiggly mx1 plus b. Okay, since we want the linear regression line, we don't care about r or r squared, so we're going to skip those for right now. Instead, we're going to pay attention to the m and the b value. So the m and the b value, we're going to round to the nearest hundredth, which means to the nearest 2 decimal places. Using this for m, it should be negative 3.12 for the m value, negative 3.12, and then for the b value, the y-intercept, it's going to be 88.9. And then just to show you, those are the values that you should have gotten right there. All right, TI-84, we're going to do the exact same thing. So make sure diagnostics is turned on. If you haven't already, press second 0 to pull up the catalog. Hit the green D right above this X-1, I believe that's the button. Scroll down to diagnostic on. Enter, enter, done. You only have to do this once. So if you've already done this, then you could skip this part. Now press stat, hit edit. Clear out what we have in L1 and L2 by highlighting the L2, hitting clear, enter, and then L1, clear, enter. And then we're going to enter all the X values and Y values exactly like we did with Desmos. So 14, 16, 18, and so on. Okay, and then enter the Y values, 45, 45, 33, and so on. Okay, every one of those should have a pair, so just make sure everything looks good. Then we're going to hit second mode to get out to the main screen. You don't have to, but I like to just so I can get out and get away from the previous screen. So then we're going to hit the following. Stat right for calc, 4 for line reg. Make sure L1 and L2 are there. If not, then hit second stat to pull those up. Whoops. And then go down to calculate, hit enter, and then it should bring everything up. As you can see, negative 3.12 is our A value, which is the M value. And then 88.90 is our B value right there. And that's it for you try number 1. And again, you can move the box and see those values, and they're exactly right there. Whoops. Okay, here's another practice. So, if you would like, pause video, try this out on your own. Create the line of best fit, round to the nearest hundredth, so 2 decimal places. Enter the table using either Desmos or TI-84, whichever one you feel like you want to do. And then check your answers by moving these boxes, see if you got the correct values. Okay, so go ahead and pause the video, try this on your own. Otherwise, I'm going to go ahead and show y'all how to do them both again using Desmos and TI-84. Okay, I'm going to go through this one very fast, if possible. So, put the table, because we've done this a couple of times already, so if you need a thorough explanation, just watch the previous sections. So, for X1, I noticed that none of them have X1 or Y1 or X's or Y's. Typically, in a horizontal table, the top part is are the X values, the bottom part are the Y values. So, the training hours, these are all the X's. And then the accidents, these are all the Y's. Okay, so for training hours, we have 0, 12, 2, 10, 9, 5, 6, and 4. For the Y values, we have 8, 0, 5, 1, 3, 2, 2, 0. Then you can see right there the dots populating. You can zoom in, zoom out, whatever you want to do. Now to create the line of best fit, we're going to go to line 2 and then type the following. Y1 squiggly MX1 plus B. And then there we go. We have the line of best fit. Okay. Now, M value, round to 2 decimal places, should be negative 0.48. So negative 0.48. And then for the B value, it is 5.52. All right. And that's it. That's the line of best fit. Okay, that's the Desmos calculator. You can look behind here to check, and looks like we did okay. So now to show y'all on the TI-84. Make sure diagnostics is on. We're going to go to Stat, Edit, and then if there's anything there, just highlight and clear it out. And then enter what we did like before. X's are training hours, and then Y is accidents. So we have, because again, typically in a horizontal table, the top part are the X's, and then the bottom parts are the Y's. So we have 0, 12, 2, 10, 9, 5, 6, 4. And then for the Y values, for the L2s, L1s are X's, L2s are Y's, we have 8, 0, 5, 1, 3, 2, 2, and 0. Make sure every one of them has a pair. And then you can go straight into your calculation, or you could quit out into the main screen, which I like to do by pressing second mode. And then you do the following: stat, arrow to the right for calc, option 4. Make sure L1 and L2 are right there. And then go down to calculate, hit enter, and then it'll show up the same numbers that we used for from Desmos. Except the equation it has structured is A instead of M, and then B, well, B is the same. It's just the M changes to A. And that's it. That's it for the TI-84. Then you can see right there, we have the exact same values right there. And that's it. That's it for you try number 2. Okay, some more problems interpreting equations. Remember the slope intercept form, M equals the slope, B is the y-intercept. So in this example, the equation y equals 3.5x plus 60 gives the cost y of renting a car if the car is driven x miles. So y represents the cost of the car, x represents the amount of miles driven. What statement is true? So read through it, see if you can figure it out on your own. Otherwise, I'm going to continue on and show y'all how to do this, or how to think about this. So if you would like, pause the video, figure this out before I give y'all the explanation. So x represents miles and y represents the cost. Now look at the equation. Y equals, another way of saying it, y depends on x. X is the amount of miles that you drive. Y depends on the amount of miles, because 0.35 for renting a car, that's how much you pay for the amount of miles that you drive per mile. So 0.35 times the amount of miles plus an extra $60 charge for whatever reason they give for renting the car. Okay? So that's our interpretation. Because math, remember, is a lot of English. We interpret the English, we interpret the real world stuff into math symbols. And from that those math symbols, we solve, we simplify, we answer stuff in a different way, and then translate it to the real world. So it's just a bunch of translations going on. Y depends on the amount of miles, because it's 35 cents per mile plus $60 or whatever. Maybe there's a fee to it. I don't know. Okay? So now that we know the interpretation, let's look at which one best fits that interpretation. For every mile the car is driven, the cost increases by 35 cents. Well, yeah, that makes sense. If it's 1 mile, you have 35 cents. If it's 2 miles, it increases by 35 cents again. So far, looks okay. For every mile the car is driven, the cost decreases. That doesn't make any sense, because there's no negative. It doesn't decrease every mile. So, B, no good. For every mile the car is driven, the cost increases by 60. While the cost does increase by 60, that 60 is not dependent on the miles. The miles go for a different rate. This 60 is a different charge altogether. So, C doesn't make sense. It does not increase 60 per mile, because if that were the case, 60 would be right next to the X, and it's not. D, for every mile the car is driven, the cost decreases by 60. Again, 60 is not associated with the amount of miles. It could be a whole separate thing that we don't know about. So the only one that makes sense is letter A. For every mile the car is driven, the cost increases by 35 cents. And that's it for this poll. Let's go through another one. The equation y equals 4.75x plus 20 gives the cost of towing a car if the car is towed x miles. according to the model, what is the best estimate of the cost for towing a car 22 miles? So again, if you would like, go ahead, pause the video, try this part on your own, see if you can understand it. Otherwise, I'm going to continue on and show y'all how to do this. So, the question, according to the model, what is the best estimate of the cost? What does cost represent? Well, if we look earlier in the problem, the cost y. So, basically, we're trying to find the y value. What is it? We don't know. But we do know that we want to find the cost for towing a car 22 miles. Well, what represents miles? In this case, x represents miles. We can find y by replacing x with 22. Okay, so we're going to do the following. And I gave you all the hints right there, but anyways. Y equals 4.75x plus 20. We're going to use 22. Let me highlight this with a different color. We're going to use 22 for x. So then we're going to have 22 being multiplied with the 4.75. And then after we multiply that, we're going to add 20. And then we will have y. Okay, notice we don't have to do anything else other than plug in and use the calculator. Y is by itself, so there's nothing else we need to do. It doesn't matter what calculator we use. I'm just going to use the TI-84. So we're going to enter the entire right side of the equation as such. 4.75 parentheses 22 close parentheses plus 20. And then we have 124.5. So in terms of money, this means $124.50. Letter D is the best estimate answer. Then you can see right there, that's exactly what we did. They broke it down a little bit more, but we just entered it all into the calculator and got our answer. That's it for this example. All right, let's talk about coefficient of determination, which in other words, the R squared. So in regression, the R squared coefficient of determination is a statistical measure of how well the regression line approximates the real data points. An R squared of 1 indicates that the regression line perfectly fits the data. So R squared is a statistical measure that helps explain helps show you how much of the data can be explained by this relationship, the relationship between the x and the y. So a kind of like linear regression or a correlation coefficient, a number from R squared closer to 1 tells you how reliable it is. A number closer to 0 tells you that it is less reliable. Okay, so for example, if you have R squared equals 0.89, then we could say that this is fairly reliable, that the relationship between x and y a lot of it can be explained by this relationship, or at least according to the math. Doesn't always mean that they're related, but just whatever it is, the data that you're using according to the math, it is reliable. Hope that makes sense. Now, if we have a smaller number, like let's say 0.39, then the model is less reliable. You can't really explain much or too much using the data given from your model. Okay, so that's what R squared tells us. Now, we'll go into more of an explanation in a little bit. But anyways, when you go into your calculators, you should see an R squared there. That R squared tells you It is the correlation. I'm sorry. It is the coefficient of determination. There's just a lot of big names in this section. The coefficient of determination, which tells you how reliable this data set is. Okay. It also explains a percentage. What percentage can be explained by the data given, by the model. So that's what we call the percent of the variation. So the coefficient of determination, R squared, is also called the percent of the variation. So to find the percent of the variation, we're just simply going to take the square, the correlation coefficient, make sure it's squared, and then change it into its percent form by multiplying it by 100. Okay? So let's go through an example and a you try. So in this model, let's say we've gone through the calculations. I'm going to pretend we don't have this answer yet. Let's pretend we've entered this into the calculator. We've gone through our calculations, and we were given the R value. Well, now we want to know what percent of this model can be explained by, or this relationship can be explained by this model. So the R, let's say we found the R to be 0.99576. Okay? Well, to find the percent of the variation, we need to square it. So in parentheses, I'm going to type this number in, 0.99576, close parentheses, and then you can do this one of two ways. You can either use the square button, which is right above the log, to get that little 2 there, or you can use this caret symbol to move your cursor up into that little box and then press the number 2. Hit enter, and then you'll get the square. So 0.992. Well, it says 0.9915 right here, so we'll just use that. Now we're going to change this from its decimal form to its percent form. Multiply by 100. Then let's chop it off to about 2 decimal places. What does this mean? So this says about 99.15% of the variation in the number of subscriptions can be explained by its correlation with the number of years after 1990. Okay, so that means there's a high correlation between the two different things: the years after 1990 and the subscriptions per 100 people for the mobile seller, whatever this graph is talking about. Okay. Now this also says that about 0.85, so 0.85%, which is nearly 1%, can't be explained by this model, by this relationship, the variation. Okay. So this is saying that you have some data in here that's just not explainable. But you have a high degree, a high percentage that can be explained by the variation of these two different things: years and subscriptions. So this is a very reliable model to predict things with. Okay, so here's an example. Let me block some of these. I'm going to pretend you didn't see it. The correlation coefficient R between an employee's age, X, and the yearly salary, Y, is 0.575. So employee's age and yearly salary. The R is 0.575. What percent of the variation is yearly salary in yearly salaries can be explained by differences in the employee's age. So, first step is to square the R. We know what the R is. The correlation coefficient R is 0.575. So, we're going to square that. Do the following, parentheses, .575, close parentheses, and then square it. And you don't have to put the parentheses, but it's for a specific reason. There may be negatives associated with R, and if you don't put the parentheses in, then it'll calculate it wrong when you square it. Okay, so just to be safe, I put parentheses around that number when I square it, no matter what. But anyways, when I square it, I get .330625. Now change it to its percent form by multiplying it to 100, or moving the decimal place to the right twice. And we get 33.06%. Okay, so this is telling me 33.06% of the variation in yearly sales can be explained by differences in the employee's age. But that also means about 66% is explained by something completely different. So employee's age is only a little part of the explanation to the variation of the yearly sales or salaries. There's another component that's not being thought of in this model. Okay, so that's the interpretation. And that's what I was trying to say with this one. There's 0.85% that can't be explained and is instead explained by a different variable. Same thing here. 33% can be explained by differences in the employee's age, but then there could be something else. It could be work ethic. It could be the amount of hours that they're working, etc. We don't know. It could be some other variable. But we do know 33.06% is explained by the employee's ages. That's it for the example. Okay, here's you try number 3. Read through the problems, enter the steps 1 and 2 if you're on ClassKick. The correlation coefficient R between the number of miles driven X and the number of gallons of gasoline used Y is 0.925. Excuse me. What percent of the variation in the number of gallons of gasoline can be explained, by differences in the number of miles driven? Step 1, square the correlation coefficient. There you go. And then just enter it into the calculator. Check your answer by moving the box. See if you can figure it out. And then step 2, change the decimal answer to a percent. Round your answer to 1 decimal place. So at this time, pause the video. See if you can figure this out on your own. Otherwise, I'm going to continue on and show y'all how to do this. So we know the R value is 0.925, but we need R squared. So we're going to take 0.925 in parentheses and then square it. And then we get the following, 0.855625. So just to answer what's in here, this is 0.925 squared. And then we get that entire decimal, 855,625. So 855,625. Now, change it into its percent form by multiplying it by 100 or moving the decimal place to the right twice. I'm going to go the easy way, multiply by 100. 85 point, and then what does it want? 2 decimal places. No, I'm sorry. Do I even say? Oh, no, yes, I do. It says round to 1 decimal place. Sorry about that. So this should be 85.6 because when we stop at the 5, the number next to it is 5 or bigger. So that means the number we stopped at rounds up to the next number. So this is 85.6%. Then you can see your answer right there. And there it is. So this is saying that 85.6% of the variation in the number of gallons of gasoline can be explained by differences in the number of miles driven. Conversely, That also means about 14.4% is explained by something completely different. We don't know what it is. Could be some other different factor, could be an environmental factor, could be a human factor, no clue. We just know that 85.6% can be explained by differences in the number of miles driven. And that's it for you try number 3. Okay, that's it for 3.04 notes. If you need anything, let me know. You have my phone number right there. And email, text me or call me, doesn't matter which. After 5 p.m. though, I tend to answer less. But if it's an emergency, use my phone number. And if it is an emergency that you need to know right now or need help with, I'll try to answer it as soon as possible. Okay. Otherwise, email me, whatever. Just let me know if y'all need anything. Okay. So that's it for the notes. Have a good day. Take it easy, everybody.